Hey girls, we're going to have a look now at the next couple of questions on your sheet. So the last video clip was about the advertising sign outside an optician's. Let's look at these shapes here now. What we're going to do is find the positions of the centre of gravity of these unusual shapes, and then we're going to have a look at what happens if they're suspended from one point. So I'm going to take these two, I'm going to do F first of all and H, and then you're going to do these two there. A giant letter is cut from a thin uniform sheet. So I'm looking at this one, this F. Find its centre of gravity. So that's the first thing we're going to do. So if we take, I've just transcribed that diagram into here. So what we're going to do is use the law of moments to do this. Right, so the things we need the forces, we need the positions of the centre of gravities. We're going to need the moments about the x-axis and the moments about the y-axis. I'm going to divide that shape into three manageable pieces. So I'm going to drop a line down here. So now what I've got is three rectangles, which is easy to find the centres of gravities in the areas of. So I'll mark them A, B, C. And I'll set up my table based on those three shapes. So A, B, C and my three shapes. Now, the forces. So for A, I'm going to use the link again that W is the force per unit area. So weight, one unit of weight is the force per unit area. So if I find the area of the shape, that I'm going to regard that as its force or its weight. So you can see A has an area of, because it's a rectangle, length by breadth 5 by 1, so that's just 5. And I'll say 5W because the force per unit area is W. B, I'm going to find the area of B, which I can see is the whole length from here to here is 4. 1 is gone already, so this part from there to there is 3. 3 times 1 will give me 3W. And C, the force for C is going to be the area multiplied by W. So in this particular case, it's 2 by 1, so that's 2W. Okay, the positions of the centre of gravity for A, B, C. The position of the centre of gravity of A is right slap bang in the middle of A, so it's here. So what position is that? If I take, I'll need sort of an axis to help me. So I'm going to have an imaginary x-axis going through, a y-axis rather, and an imaginary x-axis going this way. And I'm going to base then, say my coordinates around these imaginary x and y-axis. So if this is the origin 0, 0, that means that slap bang in the middle of position A, I would be at a half, so half along and 2.5 up. So the centre of gravity of A is there. Look at B, B's over here. Remember, I've got to go, if this is my origin, I've got to go out 1, and then I've got to go out another 2, another 1.5 to get into the middle of B. So that will give me, from the origin out into the middle of B along the x-axis will be 2.5. And going up the y-axis, I'm going up 2, 3, 4.5 along into B's rectangle. That's going to give me 4.5. And then C, the centre of gravity of C, slap bang in the middle of that rectangle, I'm going to go 1 out and then another 1 out, so that's 2 along the x-axis, and how far up the y-axis I'm going 2.5. So stop the video at this stage and make sure you understand where those numbers came from. Okay, the moment about the x-axis I'm going to get by multiplying the force by the distance. So about the x-axis, the distance from the x-axis is 2.5, and when I multiply 5 by 2.5, I'm going to get 12.5. When I multiply 3 by 4.5, I'm going to get 13.5. And when I multiply 2 by 2.5, that's going to give me 5. Then I'm going to get the moments about the y-axis. This is going to be 5 by 1/2, which is going to give me 2.5. And these are all times W, I forgot that. The moments about for B is going to be 3 times 2.5, which is going to give me 7.5 times by W. And the last one, of course, is 2 by 2, which is 4W. Right, so I have my table set up. I'm going to use the law of moments. I'm going to get the resultant, which of course is 10W. I don't know where the centre of gravity is, that's the position xy. The moment's about the x-axis. When I add these fellas up here, that's going to be 31W. And when I add these fellas up here, that's going to be 14W. Okay, then I'm going to do the law of moments. So the law of moments. The sum of the moments equals the moment of the sums. The sum of the moments about the x-axis, that's going to be 31W, is equal to the moment of the resultant about the x-axis will be 10W by y, which means that y is equal to 3.1. And then I'm going to do the same about the y-axis. So the sum of the moments about the y-axis is 14W, and 14W is equal to 10W by x, which means x is equal to 1.4. So my centre of gravity for that shape is 1.4, 3.1. Right, second part of the question. If this F is suspended from the point P, find the angle which the side PQ will make with the vertical when it is in equilibrium. Okay, so F is suspended from the point P. So here's my F. If it's suspended from the point P, it's going to swing around like this. So it's going to be something like that. That's how it's going to hang. And when it does hang, its centre of gravity will be on, we'll say, the plumb line, the line that points down towards the centre of the earth. So that's the plumb line, that's where its weight's acting, down towards the centre of the earth. This is the angle here, I'll call that angle alpha. That is the angle now that the shape makes with the vertical. Okay, so I know where the central gravity of that shape is because I'm after finding that. It's at 1.4, 3.1. So 1.4, 3.1, if I look at it from here, 1.4 out the x-axis and 3.1 up the y-axis will bring its centre of gravity to somewhere around there, so just above the C position. So if I look at that here, just above the C position, it would be about there. So that's where the centre of gravity is. Now, I know where the centre of gravity is. It's at 1.4, 3.1. So 1.4 out, 1.4 out, 3.1 up. So this is 1.4 out, from there to there, it's 1.4, and 3.1 up. Now 3.1 is from there to there. And I know that the whole distance is 5, which means that this little part here has to be 1.9. Right, so what I'm going to do is I'm just going to, if you notice now, look what I have a right angle triangle. So this is 1.9, this distance here is 1.4, and this is that angle here, alpha. So I've just removed this little triangle. See that triangle here? I've just removed that triangle and here it is. Of course it's a right angle triangle. So I can find alpha very easily by saying that the tan of alpha is equal to the opposite over the adjacent. And when I get arc tan of that, I end up with 1.5, the second function tan of that gives me an alpha of 36.38 degrees. Okay.